Hello everyone. In this lecture, we will see the multiplexer and also we will see the Verilog code with all type of modeling in Verilogs. So here, multiplexer, it is a combinational circuit with more than one input lines and one output lines. And to select a particular input lines, we have a select lines. So combinational circuit is the circuit which whose output depends only on the present inputs, and the multiplexer is one of the device. Now, if I want to draw the block diagram for multiplexer, it will have a multiple input lines. It will be denote maximum. It will be 2 raised to power n input lines. Similarly, we have a single output line. This is output, and it will be denoted by 2 raised to power n is to 1. Along with that, to select a particular input lines, we have the select lines. To understand multiplexer better, you can take an example of our TV remote, because if you see multiple channels are coming, and by using the remote you assume as a select line. So if you see, for example, we are having almost 300 channels, you assume as the input lines. We are having multiple input lines. From the remote, we are giving certain selections. For example, you are pressing 2 1 2. So particular channel you can see at the output. So the best example is the TV and TV remote and the screen. Okay, so multiple channel you can assume as an input line. By using the select line, we are selecting particular channel, and thus that particular channel you can view as the output. Now, for example, I am assuming the basic multiplexer with two select lines. So with two select line, if I draw the block diagram here, so we will have two select lines here. I am assuming this is S1 and S0. Similarly, we will have a multiple input lines. How many? 2 raised to power maximum. So if you substitute 2 here, because it's 2, n is equals to 2, and select lines, then there will be 4 input lines. I'm assuming this is I0, this is I1, this is I2, and this is I3. You can write down this is 4 cross 1 mux. This is output, and that you can assume as Y, for example. So here I am discussing 4 cross 1 mux, right? Now, if you want to draw the truth table for it, so here we will write down the input. We will have the select line S1 S naught, and this is the output Y. In the input, either we will get I0, you will get I1, I2, and I3. And as we have two select lines, total possible combinations will be 4. 0, 0, 0, 1, 1, 0, 1, 1. What does it mean? If you press 0, 0, I0 channel will be connected to the output. So at the output, I can see I0. If you press 0, 1 from the remote, you can select channel I1, and that you can check see at the output. So I1. Similarly, from by using or by pressing 1 0 from the remote, you will see the channel I2 at the output. So you can write down I2. Similarly, if you press 1 1 from the remote, you will see the channel I3 in your TV set, right? So this is I3. So now we can write down the expression. Why? Because you know that output, we will write down the expression for its output. So Y will be given as S1 S naught. So it's 0 0. So you can write down as S1 bar S naught bar I0 plus, right? This is 0. S1 is bar, S naught is bar, I0. Similarly, for this one, it is S1 bar S naught I1 plus S1 S naught bar I2 plus S1 S naught I3. So this is the expression. Now we can use the circuit diagram to we will use this expression to draw the circuit diagram. So here, uh, first will be the AND gate. Here you can give I0, here I0, and here you provide S1 bar, S0 bar, right? Similarly, the next AND gate, in the next AND gate, it is S1, I1, here it is S1 bar, this is S0. Similarly, for the third AND gate, we have to provide S1, S0 bar, and this is I2. Similarly, we have to draw the third AND gate. In the third AND gate, we have to write down, this is I3, this is S1, and this is S0. All you have to provide to the OR gate from the expression, you know that, and that will be given to the OR gate. And this is your output Y. So now we are ready with the expressions and circuit diagram, and along with the truth table, we will go for the Verilog coding now. In the Verilog coding, we have three types of modeling. We will start with the first one, that is the data flow modeling. For the data flow modeling, we should know the logical expression. Okay, important part is what? We should know the logical expression. Why? Because data flow modeling will be based on logical expression. So that expression we calculated or we derived, I'm writing here also. This is S1 bar S0 bar I0 plus S1 bar S0 I1 plus S1 S0 bar I2 plus S1 S0 I3. This expression we have to write down by using the data flow modeling. So how to start a Verilog coding? Always start with a module. Module is the keyword. Module is the keyword, and you can give any user specific name here. For example, I am writing for mux, so I am giving mux. After that, you have to write down all the input output that is used inside the program. Okay, so here, as we are going to use S1, I am writing S1 comma S0 comma I0 comma I1 comma I2 comma I3 comma Y. So you can see I have written all the input outputs that we will use inside the program. After this line, you have to describe which variable will work as the input for us. So here you write down input. Input is the keyword. Okay, this is the keyword. Module is the keyword. After that, you have to describe which will be the input. So S1, S0 that we are giving from the remote, and these are the input lines, right? So these are the input channel for us. So it's now I0, this is I1, I2, and I3. This will work as an input for us. Now output again is the keyword, all with the small letter. Only Y is the output. In the multiplexer, we have a multiple input and the single output. Now these are the keywords underlined, right? Underlined. And mux is the user specific. This is user specific. User specific. User specific means it can be changed by the user. After that, assign is the keyword that we use in the data flow modeling. After that, why? Before writing the expression, we should know some basics. And for that, I'm drawing it some here, here operators and symbols. So here I'm writing the symbol that we will use for the different primitive gates. Negation symbol is used for not, and this symbol we will use for the AND gate. This symbol we use for the OR gate. Cap symbol we use for the XOR gate, and rest all are the combination of these symbols. So here we have to write down. First expression is what? S1 bar. So we will write down equals to, start the bracket, negation of S1 and negation of S0. See this expression, and I0. Completed. First part is over. OR is defined by this symbol, and then I will write down in bracket S1 and operation S0 and operation I1, close with the semi, close with the bracket. After that, again use the OR symbol. Then this is S1 and operation, negation of S0 and operation I2, close with the semi, close with the bracket. Again use the OR symbol. This is S1 and operation, S0 and operation I3, close with the bracket, close with the semicolon. End module, write down end module without any space, without semicolon. Always remember end module will be written without semicolon and without space. Assign is the keyword, end module is the keyword, right? So this is the first type of modeling, that is data flow modeling. Now we will see the second type of model. Starting three lines will be same, that is the module. So it will start with a keyword module. Then you have to write down the user specific name for this program. For example, I am writing MUX1. After that, you have to write down all the input output variables that you are going to use inside the program. And as we have seen, S1, S0, I0, I1, I2, I3, Y. These are all the input output combination that we will use inside the program. After that, you have to define which variable will work as the input. So here, as you know, it's a multiple input, single output. So here I0, I1, I2, I3, these are the input variables. Along with that, we will have a select line as the input, S1, S0, close with the semicolon. After that, output is the single. In the case of multiplexer, we have multiple input and a single output. So Y will be our output. After this, we have to use the gate level modeling. Here, the name will be used for defining the particular gate. Just like here, I am writing for AND gate, we have to use A and D, small a and D. Similarly, for NOT gate, we will use small not, NOT. Similarly, for OR gate, we will use small or. Similarly, for XOR gate, we will use XOR. So these are the symbol that we have to use. For XNOR, we will use XNOR, all the small letters. Similarly, for and or not, and then we will have NAND gate, so capital NAD. For NAND gate, we have to write down small ND. So that means what? For all the gates, we have the name in the gate level modeling, and that will be defined as small letters. Now here, for NOT gate, for the NOT gate, I will write down a small NOT and some user specific name. For example, I am giving A_1. And how to write down in the gate level modeling? After the gate, for example, you are writing AND gate, it will be output, comma, inputs. Because in all the logic gates, we have single output and multiple inputs can be possible. In the NOT gate, output we will store somewhere. So we will take some intermediate variable. For example, I'm writing S1 underscore bar to store the NOT operation of S1. So that intermediate variable also will be defined by using the keyword wire. So this is S1 underscore bar. Similarly, we will use NOT A underscore 1 to store the NOT operation of S0. That is S0 bar under then comma S0 close with semicolon. And how to give the preference? Because in any circuit we can have all type of basic gate like NOT gate, AND gate, OR gate. So the preference will be given, like always give the preference to the NOT gate first, then you give the preference to the AND gate, and then you give the preference to the OR gate. Okay, so we have written all the NOT operation that was there in the circuit. Now we will use the AND gate. So here you see in the expression also, in the expression we was having Y is equals to S1 bar S0 bar I0 plus S1 not S0 I1 plus S1 S0 bar I2 plus S1 S0 I3, right? So here we have taken S1 bar over, S0 bar is also over. Now we have to store this data, first min term, in some variable. So first I am just taking this intermediate variable S0 underscore bar and is defined as a wire. After that, these intermediate terms of as min terms we will store in some intermediate variable. I am assuming this is y1, this is y2, this is y3, and this is y4. Okay, so the resultant of this AND gate we will store in some intermediate variable, and we are assuming as y1. So here you write on y1, comma y2, comma y3, comma y4. Okay, and close with the semicolon. Now, as I told you, the preference always give to from the NOT gate and then AND gate. So now I'm giving AND A underscore this I have taken as 2. Now you take as A underscore 3. Now, what is the way of writing inside the AND gate? Inside the bracket output, comma input. So I am assuming y1 will be the output, comma input will be what? S1 underscore bar, comma S0 underscore bar, close with the semicolon. Similarly, for the next min terms, the data will be stored as y2. This is the intermediate variable. So and A underscore 4, then y2, this will be storing this data, s1 underscore bar, comma s0, close with semicolon. Similarly, this third term, min term, data will be stored and A underscore 5, y3, comma, this is s1, so s1, comma, s0 underscore bar, close with semicolon. Fourth term will also be stored here, and A underscore 6, y4, this is the intermediate variable. This is s1, comma, s0, comma, oh sorry, I3. So for this one also I0 was there. So you include I0 here, comma, just changing the color. So in this expression, we was having the I0. So include I0, comma, close with semicolon. Similarly, here also you include I1, close with semicolon, include I2, close with semicolon, I3, close with semicolon. So now you see the first term is what? S1 bar, S0 bar, I0. Second term is S1 bar, S0, comma I1. Third term is Y1, Y3, S1, S0 bar, I2. Similarly, the third expression is S1, S0, I3. Now you see, after this, we have to use the OR gate, right? We see after every symbol we have OR operation. So that OR I am using it here, A underscore 7. And we already saved this data as Y1, Y2, Y3, and Y4. But output we will store in Y. So Y, this is output, comma, all the inputs that are Y1, comma, Y2, comma, Y3, close with semicolon. And this is y4. So here I'm writing y3, comma, y4. All the input you write down, close with the semicolon. Then the last word will be end module. Right now, we will write down the behavioral modeling. So for the behavioral modeling, we should know the truth table. Here I am drawing the truth table for just for the reference. So here I am taking S1, S0, and this is Y, 0, 0. So it will give you the value of I0, 0, 1 will give you I1, 1, 0 will give you I2, and 1, 1 will give you I3, right? So here we will see the behavioral modeling now. So in the behavioral modeling, we require this truth table. That's why we made it. Now in the behavioral modeling, the starting 3 lines will be same like module, and you have to write down some user specific name. For example, I'm writing mux2. Now write down all the input output variables like s1, s0, comma, I0, comma, I1, comma, I2, comma, I3, comma, Y, close with semicolon. Then input here will be S0, S1, I0, I1, I2, I3, close with semicolon. Similarly, output will be Y. So this is the same for all type of modeling. The starting 3 lines will be same. After that, we have to store this output as a register, because in the register only we have to make this truth table. So we will define this output as a register file, reg y. Then we have to say that any of the input can vary. right? So here always at the rate S1 or S naught or I naught means any of the input can change, and it will the change in this input will affect your truth table. I1 or I2 or I3. Close the bracket. No semicolon here. After that, you have to begin. After begin, you write down case statement. That means here, if you see the truth table, in the truth table, only S1 and S naught are there, right? So in the case statement, we have to write down by the change in. So by the change in S1 comma S naught curly brackets and the bracket closed. Now we have to write down 2 dash B 00. What does it mean? In the truth table, if you see the if the S1 and S naught values are 00, Y will be equals to I naught. How to write down this one? Then you, after 2 dash B 00, that means if S1 and S naught are 00, then begin Y equals to I naught, close with semicolon, end. Similarly, we will write down the second line of this truth table. It says that if it is 0, 1, then Y will be Y1. That means how to write down in this truth table? 2 dash B01. That means S1 and S naught are 01, colon, begin. In that case, Y will be equals to I1, close with semicolon, end. Similarly, 2 dash B10 begin, Y is equals to I2, close with semicolon, end. Third line or fourth line, 2 dash B11 colon begin, Y is equals to I3, close with semicolon, end. Now, as we initiated the case, first you close this case by end case, all small letter without semicolon. Then we have written begin, so begin will be end here. So here you can write down like this. This is end case, then this is what? The end, and then you have to write down end module. That's the end of behavioral modeling. So in this lecture, we have seen multiplexer with three types of Verilog modeling: data flow, structural, and behavioral.